What does converse mean? We did that back in chapter 2. So flip back in your notebooks, find chapter 2. It was a foldable. I think it was 2-4 part 1, 2-3 part 1. Right there, that foldable. Switching places. What kind of statement are we dealing with in a converse? If then. So remember, it's an if then statement. So like if A, then B. A converse means we're going to switch places. So we're going to switch that over. Instead of if A, then B, how would that switch? If B, then A. Good. All right, so these are all converses of 3-2. So we've already learned these theorems. We're just switching them around. So I'm going to switch back to 3-2 for just a second. So if you're still writing this down, pause for a moment. Don't panic. I'm going to come back. Just breathe. You can do it. All right, 3-2. For like alternate exterior angles theorem, it started off with if two parallel lines are cut by a transversal, then the angles are congruent. So it would be our converse of this. We're going to start with if the alternate exterior angles are congruent, then no, not necessarily the transversal. That will be implied with the alternate exterior, but that the two lines are parallel. Okay, same thing here. If we do consecutive interior, this was if two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. So we're going to just do it backwards. If we see supplementary angles that are consecutive interior, then the two lines are parallel. So as we go back to this paper here, which I totally have ready to go. Okay, if you look at that middle part, it says if two lines are cut by a transversal so that ... What does the bottom conclude? Then the two lines are parallel. Good. So for this one, we're going to have 4 different theorems. They're kind of broken up into their own box rather than writing it out 4 different times. I just figured we can write that first if and the then once, and then we have 4 different reasons why. Okay? And then at the bottom there is an example that we'll work through that looks kind of like your homework today. So here we go. It says if two lines are cut by a transversal so that corresponding angles. Let's first talk about corresponding angles. So let's draw a picture of 2 lines. And they're cut by a transversal. I don't know that they're parallel yet. That has not been said. I just know that there's 2 lines cut by a transversal. And now I have corresponding angles. So remember, what does corresponding mean? Yeah, like same place. So if I look at this angle on the bottom here, what angle over here is corresponding that matches that one? Good, the bottom on the exterior. Good, I like that, bottom exterior. And when lines are parallel, what was the original theorem saying that if the lines are parallel, then these are congruent? Yep. So corresponding angles are congruent. So if we see corresponding angles that are congruent, we can now say, oh yeah, those lines are parallel. We're just doing it backwards. It feels a little goofy because you're like, yeah, I already learned this. Good. Today should be an easy day. Kind of already learned this stuff. And if you didn't learn this stuff, if you were doing that review yesterday and you're like, I don't even know what's going on, today's a good day to relearn it. All right, alternate interior angles. Again, let's draw a picture. I'm going to kind of switch it up a little bit. We don't technically know that those lines are parallel yet, so we won't use those parallel markings. But we do know that they're cut by a transversal. All right, alternate interior. So interior means inside. So I need an inside angle. I'll go with this one here. I'm going to use 2 arcs there to show that it's going to be congruent to the other alternate interior angle, the pair. So I go to the other intersection down here. I want to go inside, so it's kind of above. Do I want it to be on the same side of the transversal or the opposite side? Opposite. Good. All right, and with alternate interior angles, we want those to be congruent. So we want to put that congruent symbol somewhere. You can write out the word congruent. How are we feeling so far? Making sense? Remembering it? All right, consecutive interior angles. So again, we're going to have those 2 lines that are parallel. I'm just kind of trying to switch up how they look, but we don't know that they are technically parallel. We don't have those markings. But what we do know is that our consecutive interior angles are shown. So how is that different than alternate interior angles? Good, they're going to be on the same side of that transversal. So like on this one, if I go on the inside here and I go on the top, my consecutive, I'm going to go to my other intersection. It's going to be on the inside, so kind of on that left side, and I want it to be on the same part of that transversal, so on the top. This time on this side, though, I'm going to use 2 arcs. Because with consecutive interior angles, they're not necessarily congruent. With consecutive interior angles, they are supplementary. All right, and what does supplementary mean again? Good, they add up to 180. So again, if you want to write that somewhere, so that way you remember as we're working. Sometimes, especially like when you're taking a test, you panic, and you're like, supplementary, I know that word, but we forget what it means. So just adding in that little hint for us is going to be important. All right, alternate exterior angles. Again, we have 2 lines that are cut by a transversal. Now this time we're going to look at alternate interior. I'm sorry, alternate exterior. Which looks really similar to alternate interior, hence why I accidentally screwed that up. But what's the only difference between interior and exterior? Good, exterior is outside. We're still going to alternate though, so one's going to be on one side of the transversal, the other will be on the other. Purple, or let's do purple. So let's look at this angle here. It's on the outside because it's not between those 2 lines. And my alternate exterior, I go to the other intersection, and I'm not going below it. I'm going to go above to the exterior. Not the same side, but the opposite side. And what do we know about those angles if they are congruent? So if we know any of these four things, then we can say that the lines are parallel. Okay, so we're going to have three examples here that we'll work through. We have three lines at the bottom that are cut by one transversal. What's the transversal that cuts through the three lines? Yeah, line L. This is a cursive L. It's not a great L, but for some reason we use it a lot in geometry. Don't love it. Okay, that's our L. So line L is the transversal. So we're going to determine if any of these lines are parallel, A and B, A and C, or B and C, based on the information we're given. And this is exactly what your practice looks like today. Okay, so given angle 1 is congruent to angle 4. So as I look at angle 1 and angle 4, they're connected by a transversal L. And what two lines would we be looking at? Are we looking at A and B, A and C, or B and C? Good. Angle 1 is up here by angle A. Angle C is down here by line C, angle 4, sorry. So I'm going to kind of cover up that angle B for a moment because we're not looking at that. We're just looking at 1 and 4. If I know that those are congruent, let's decide what their relationship is. What kind of angles are 1 and 4? Are they corresponding? Alternate interior, consecutive interior, or alternate exterior? Good, alternate interior. And we know that they're congruent. Does that tell us that these lines are parallel? Yeah, alternate interior angles are congruent. So if they're congruent, then the lines are parallel. So we're going to write what two lines are parallel here. C and A, or A and C. So remember we have that little two slashes we can use for the word parallel. So A is parallel to C. So in that situation in number 1, A is parallel to C. And we need to say our Y. So our Y just goes into which one of those boxes was it? It was the alternate interior converse. Alternate interior angles theorem converse, but we'll just say alternate interior converse. That converse is really important that we include that word because that's what allows us to say that the lines are parallel. If we just say the alternate interior angles, then you're switching up what we're given. The given would be that the two lines are parallel. Now we're saying they're congruent. We're switching it. We're starting with angles are congruent, so now the lines are parallel. All right, number 2, we're looking at angle 3 and angle 4. I was definitely also say angle 2, but let's just roll with it. All right, angle 3 and angle 4. So if I look at angle 3 and 4, they're both connected by that T, that transversal. What two lines are we looking at for 3 and 4 being parallel? Good, B and C, because 3 and 4, we're like covering up that A. It's no longer, we're not worried about it. We're just looking at 3 and 4. What kind of angles are 3 and 4? Alternate interior. When I look at 3 and 4, they're opposite sides. So if they're alternate interior, in order to say that these are parallel, what do we need to know about them? They're congruent. They have to be the same. When I look at this, are angle 3 and angle 4 the same? Nope. So can I say B is parallel to C? No. But do we know anything about angle A yet? No, A could be parallel, so what we say is just no conclusion. We know for a fact B and C are not parallel. But in this picture, we don't know if there's anything else that's parallel. So we just say no conclusion. All right, last one. Angle A is 46 degrees, and angle 3 is 46 degrees. So again, let's look. It's transversal. L connects them. It goes through both of them. Which two lines are we looking at for 1 and 3? Good, A and B. So it's like we can cover up that C for a moment. Okay, I want to look and see what types of angles 1 and 3 are. What is that pairing? And to do that, we look back up here. Is it corresponding, alternate interior, consecutive interior, or alternate exterior when we look at 1 and 3? They're corresponding. 3 is on the exterior. What about 1, though? Good, on the interior. So 1 is interior, and 3 is exterior. So that's our corresponding where they're in that same position. Okay? So that's our corresponding. And corresponding angles, do they have to be congruent or supplementary? Congruent. Are the angles congruent?
Yes.
How did you know?
Because it's given.
Well, it doesn't say angle 1 is congruent to angle 3. Good, so why is that congruent? Yeah, that's what congruent means, right? That would be our definition of congruent segments. If they're equal, I'm not segments, angles. If they're equal, then they are congruent. So they're congruent, so we can say A is parallel to B. Now this one's a little goofy. We can just say corresponding converse. If you're writing a paper and getting it published in the magazine of math, the editor would send this back to you and say there is no such thing as corresponding converse, because you'd have to say the converse of corresponding angles postulate. You'd be really professional. But right now we're going to not be professional. Is that okay? You all right with that? Cool. All right. So if you have not glued this in yet, this is the notes for today. Tomorrow we're actually going to be doing proofs where we're given, and it's a multi-step proof. But we're going to use these converses. So if you haven't glued it in yet, glue that in. And then there is a practice.